All right, what we have here today is section 9.1, which is the property of radicals. Example 1 is the product property of square roots. So in letters A and letter B, I have two expressions that I want to be able to simplify. So we're going to start with letter A, which is the square root of 108. Now the first thing I want to point out to you guys is that if I were to put this in my calculator to figure out what is the square root of 108, it's going to give me a very messy number. And the reason why is because square root of 108 is an irrational number. There's no number in the world that multiplied by itself is going to give us 108 if we squared that number. So what we do instead is we try to simplify the expression by pulling out factors that are square roots, that are perfect squares. So my first step, what I'm going to do is I'm going to rewrite this as a product of a perfect square. So 36 is a perfect square, and I know that 36 times 3 is equal to 108. So square root of 108 is equal to the square root of 36 times 3. So what I've done now is I have the square root of 36 multiplied by the square root of 3. And one of these I'm able to simplify, right? We know that the square root of 36 is 6. So now my final answer here, I'm just going to simplify that, and my final answer is 6 square root 3. Now a good way to check your answer when you're only working with numbers is, if we remember, the square root of 108 was about 10.39. Now if I put into my calculator 6 square root 3, I'm going to get that exact same number. So that's a really great way to check your work to make sure that you've simplified correctly. Now in our next example, we have a variable, but the steps are still going to be the same. So first thing I'm going to do is I'm going to pull out the perfect square factors. So I know that 9 is a perfect square. I'm going to break apart x cubed. So x squared is a perfect square. Anything with an even exponent, you can take the square root of it. And then all that's left over is just 1x. So x to the third is the same as x squared times x. I've just kind of broken it apart so that I can pull out those perfect square factors. All right, so now I'm going to just rewrite it so that I have the square root of 9 times the square root of x squared times the square root of x. I keep breaking it down further based on the perfect square factors. My last step is going to be to simplify. And what I'll do there is just kind of figure out what I'm able to simplify. So the square root of 9 is 3, the square root of x squared is x, and then the only thing that's left over that cannot be simplified further is the square root of x. So this would be my final answer. All right, so what I would like for you guys to do is go ahead and try these 4 problems on your own. Pause the video, give them a try, and then I'm going to walk you through the steps on how you're going to solve them. So to simplify the square root of 24, I'm thinking of what factors of 24 are perfect squares. So the square root of 4 times the square root of 6. 4 times 6 is 24, so I've broken that apart, and I can simplify the square root of the square root of 4, which is 2, and then the square root of 6 stays the same. The next one we have the negative square root of 80 that we want to simplify. So again, I'm thinking what factors of 80 are perfect squares. And I know that 16 times 5 is equal to 80. So I've broken apart the square root of 80 into the square root of 16 times the square root of 5. Square root of 16 I can simplify, which is 4. The negative sign still stays there, and then I have 4 multiplied by the square root of 5. So that would be my final answer there. For number 3, 49 x cubed, I'm taking the square root of. So to simplify that, again, I'm going to break it up. My perfect squares, I have the square root of 49. Now x cubed I want to break apart. I can make that times x squared times x. So all of these are still the same expression. I've just broken it apart so that I can simplify using the perfect squares. Once I simplify, I have 7x multiplied by the square root of x. And then for our last one, number 4, square root of 75 n to the 5th. So to simplify this, my perfect square that I can pull out is 25 times, now this one to break apart n to the 5th, I'm going to pull out n to the 4th because I need that even exponent, and then all that's left is the square root of n. So to simplify, the square root of 25 is 5. The square root of n to the 4th is n squared, and then multiplied by the square root of n. And that's going to be my final answer there.